Okay, let's begin. Lesson 3, Chapter 3, Class 8, Algorithms and Flowcharts. Now let's understand what is algorithm and what is flowchart. First thing is that let's understand what is algorithm. When you are starting programming, now when you are starting the learning how to write program, the first step in programming is writing algorithm. And then the second step is drawing flowchart of that algorithm. Third step is writing pseudocode of the flowchart, and then the fourth step is starting programming in the computer, writing program in any programming language. So there are these steps are there. First step is algorithm, second is flowchart, third is pseudocode, and fourth is programming. Okay, so these four steps are required for starting the programming work in the computer, starting to write the program in computer. So first one is algorithm. What is algorithm? Now let's see. An algorithm is a set of instructions written step by step serially for performing any task. So when we write instruction step by step how a particular work is to be carried out in a proper sequence of steps, now that is called algorithm. Algorithm has nothing to do with computer program directly. You are not going to write algorithm in computer. It is to be written on a paper in simple English, in very simple English or any language that we speak. Any language that we speak that you understand, we can write in a human readable language. And these steps, whatever work you are going to perform, these steps must be logically correct in proper sequence to reach up to the end, or to obtain a particular answer. Okay. Now it is possible to have algorithm for many works that we do in our daily job, in our daily life, whatever works we are doing. Most of the works are based on algorithms, and the things that we carry out, any work that we carry out, maybe for the first time also, sometimes we are instructed by some expert, some who has already done it. Those steps are also a form of algorithm. They'll tell you step 1 you do this, step 2 you do this, step 3 now you do this, now you do this, now you mix up, now you cook it, now this all the steps what is instructed one by one during the course of doing a work, that is also algorithm. Okay, so it is very simple. So it is instructions, set of instructions written in step by step serially for performing any work. A computer studies algorithm is In computer studies, algorithm is a step-by-step process of accomplishing a task. So if a work is given in the computer, what is algorithm in computer? If you ask, so you need to know that algorithm in computer means it is same thing as we talk about general life, uh, in general situation. It is meant for performing a work step by step to reach the particular answer or to get a particular output to get a particular output. A good algorithm allows writing a good program. If your algorithm is correct, your logic is correct, your sequence of commands are correct, that means your program that you are going to write based on your logic, on your algorithm, program is going to be 100% correct. So I already told you that it is the first step of learning computer programming. So writing algorithm is the first step of learning computer programming. Okay. Now we see the some of the characteristics of an algorithm. What are the characteristics? Number one, the first thing is that what should be there in algorithm. Number one, the first thing is that it must have input. So algorithm, whenever any work is carried out, there is always input. Now the input is either reading from some source or accepting it, no, from somewhere, deriving it, or input or adding it, no. So how you take the input? Reading, accepting, and input, no. So reading from a source, reading from a place, accepting it, somebody has given it, user has given it, or input, maybe take it from a value or variable, No, A is assigned, a B is assigned with some value, you take the value. So that is a way of accepting it. No, so give a value to A, and that A will be used inside a program. A will be used in an algorithm, who act as a value inside an algorithm. No, so that way the value is accepted. The first part is, the first and foremost thing is, the algorithm must have a component, a line, a statement which is asking, accepting, or taking in the value on which the work is related. Okay, the work task is related to that input or data. Second one is correctness. All instructions need to be well defined. Whatever instructions are given, add, subtract, any formula that is related with processing job, any task, it must be well defined and it must be correct. Functional correctness comes with the correct and expected function and output of the input data. So whatever is expected in the algorithm, what is correct, only that is expected in the algorithm. So correctness must be maintained in a formula, in the instructions, whatever you are given. No need to give any instruction which may be possible, may not be possible, that sort of thing should end. So any instruction that you are giving, it has to be done, it must be done, and then that's all. Next one is precision. Now each step of algorithm must be accurately specify what need to be done. So a correctness means instructions must be given correctly. So it's talking about a formula. Now here precision means the steps that you write, it must be accurately defined. Must be accurately defined or specified what is to be done in each step. The steps should be defined in the correct order to get correct result. So steps whatever we are writing, which it must be correctly given in the proper sequence. Feasibility. Now next one is feasibility. Steps of algorithm must be practically possible to apply with the available input. So whatever input is taken, step number one, that must be practically applied in the processing work. Okay. The steps algorithm must be practically possible to apply. Practically possible to apply means if you want to convert into program, it must be easily to be converted and applied in the program. Okay, now next one is finite. Finite means must have a specific output. So algorithm must have a start and definite end after successful completion of the task. So it algorithm always starts and ends. Start is starting the work, taking the input, processing, steps are given, and then end. And before end, what is there? The result is to be produced or displayed, and information is to be displayed, and then the work is complete. Whatever task is to be completed, it is completed, and then only the algorithm ends. The same manner. Now the next one is generality. Algorithms should be applicable in general real life situation by taking required input. So it should be, algorithm must be able to be applied in general life situation also. Okay, where in the data is taken and it is work is done. Now we will be talking about some examples. It will be making it more clear. It must be able to work accurately in a variety of situations and adapt well when new situation arises. Yes, if all of a sudden some situation changes, how the work is to be handled. So that also feature must be there. That also aspect must be there inside the algorithm. Okay, but suppose somebody is supposed to enter the height and somebody enters the weight. No, so if a range is given and somebody is giving beyond the range, then what is to be done? The program cannot stop. It should show a message that your input is out of the range. No, if you are not falling in any category, the program should not terminate. The algorithm should not terminate. It should show that you fall in this particular category, and if not, then you are not belonging to any category. So a proper message must be displayed, a proper message must be given out to the user. No, so in that way, instead of terminating the work, the there should be possibility to have an alternative to the problem that is coming. All of a sudden some contradicting situation appearing in the work in the task. Okay. Next one, output. Algorithm is written for problem solving, therefore it must produce required information. So last and very important, algorithm we are not writing for time pass and filling of the page. Algorithm is to perform some work. So what work it is supposed to perform, what answer it is supposed to require to get. So it must be serving the purpose of reaching or getting that answer or producing that information. Okay. So the end is output. So first is input, second in between precision, accuracy, processing. These all are part of processing, and the last one is getting output. Okay. Now we go into understanding the problem solving. Now what are different types of problems that we come across in our computer, in our general life? So the problem that we solve using computer science technology is called computerized process. Now the problem is there, which we are supposed to do mentally, and for human mind, it is too heavy for us to handle the huge amount of calculation and process in a very short time. No, so that is why computers are used with the programs and softwares to carry out that work, and that is why the solution to the mental work, which is performed by computer science, is called a computerized process. Okay, so the task which is performed by computer science is called computerized process, because computer is going to handle input, processing and output, and ultimately the work is done. So instead of human mind, a mental work, no, manual work and mental work, the work is processed and done by computer. Okay, next one is scientific and engineering work. In the field of scientific and engineering work, what is done? What kind of problem is there? The problems are all related with mathematical calculation. No? So a lot of calculation, a lot of physics rules and chemistry rules and mathematical rules are there, which is to be performed. So therefore, scientific and engineering works in the problems are based on mathematical problems and solvings. Okay. Now third one, commercial. Now in the commercial means in the business sector, what kind of problems are there that is to be solved by all the businessmen, all the commercial houses? The accounting, it is all related to oriented. Accounting oriented. That means dealing with the accounts, transactions, income, expenditure, tax, revenue, no? So profit, loss, all these are coming under accounting. So therefore, commercial problems are solved or they are looked into by accounting jobs. That is accounting. It is based on accounting uh, task. Okay. Now next one, we go on to the next one is this down. We go on to okay. Solving a problem in any area need to have well-defined solution. A problem solving starts with a specification of the problem and then developing a good algorithm to get accurate answers. So solving a problem is always problem solving is not simply that I like it and I can do it and do it. No, there is a proper method of doing it. So solving a problem in any area need to have well-defined solution. So the solution, how the thing has to be done, it must be well planned, well systematically organize all the steps, all the commands, all the formulas, one after another, and then only the answer, the ultimate output, what is expected, we can get. Okay, we can get accurate answer, we can get required answer only when all the process of input and then all the sequence of commands are written correctly in algorithm. A problem solving starts with a specification of problem and then developing a good algorithm to get accurate computer coding. So the accuracy of algorithm can help you to get accurate programs. So if you are able to write a good algorithm, accurate algorithm, functional algorithm which is practical, then that algorithm can help you in writing a very correct program in computer. Okay. Now let's see steps of problem solving. Now we can see one by one. The problem specification. The first work in algorithm is to specify what problem is to be performed. Know the problem clearly. What kind of problem it is? Is a normal number calculation, formula, division, interest calculation, fractional number handling, or decision making, or arranging the text, no, or sorting. What kind of problem is that? We have to first clarify, clearly understand what type of problem we are going to handle. Okay, so asking relevant questions from the problem provider. So one who is asking you to do the work or making a program or asking you to do some work, you must ask clearly what should be done. No, what are things required? Okay, like somebody tells you that okay, today you make a pizza. Now you will have to ask what are the ingredients required, what are the steps you need to follow. I need to follow. Now how can I cook? What kind of things are required in the kitchen? No. So same thing. Clarify before you start writing algorithm. The questions must be asked related to the problem. What specific things are required. So problem specification is very important. Description, you must know the full detail about the problem, the task that is given to you. Number two, problem understanding. Understand the problem. What is definite input is coming? What is the definite processing steps that I'm going to follow? The formula that I'm going to follow, or decision making that I'm going to follow, alternatives I'm going to follow, and then what output is required for the work. What answer is expected? In what format answer is expected? Even that is also to be considered. Know the source of input, from where the input is coming. Is it reading from hard disks? Is it the input is given by user? Now what formula you're going to use? What format answer is to be displayed? Single line, multi-line, descriptive, just random one answer only. The nature and validation rules. In what nature answer is to be produced? Whole number, fractional number, no, for the output before you proceed the steps. So you should know all this. You should answer. You must have clear picture of these things before you start writing algorithm for any processing. Okay. Now this all descriptions are given for a very accurate and program oriented algorithm that we write related directly to the computer program. Now number three, we are going to writing steps in simple English, the keywords used in high level languages. Okay, so what you can do is that number three, steps of writing algorithm, writing steps in simple English, the keywords used in high level program language. So possibly you can use some of the command words that we are using that are used in programming language, like print, end, input, read, data, no, if, okay, go to. Now these are the common words which I use in programming. So therefore, try to use these words in your algorithm to make it compact and which can be easily converted to flowchart and flowchart to program. Okay. So keywords used in high level languages and programming can be encouraged to use in the algorithm. Keep the steps simple and understandable to even a layman. So whatever steps we are writing, describing the work in simple English, it must be so simple that even a layman who has no knowledge of programming should also understand that your logic is going in the right way. Your logics, your steps are going in the right way. Even any person should understand what is your logic and how the work is to be performed. Now, for example, one is given here. If you are going to prepare a cup of tea, the steps what you need to follow. Now, this simple step. Step number one, what do you take? Pour water in a tea pan. Then step two, add sugar to it. Step three, add tea leaves. Step four, boil it. Now boil the above mixture. Step five, add milk and boil again a little bit. And then step six, sieve and serve the tea in a cup. No? So these all are the steps that we follow. If these steps are going up and down, then things is going to be disastrous. Instead of tea, it will become something else which you may not consume or anybody will not like to consume or drink or take. Okay. So therefore it is very, very important. Now we go to step number 4. That what is required for programming. Checking of contradicting situations and modifications. Add further detail and description required for the process. Consider the capabilities of computer language, and it should be such that anyone could use it for computer programming. Yes. So checking for contradicting situation and modifications. So always keep possible chance of modifying your algorithm. Okay. And also always keep a chance of handling the contradicting situation. Any sometimes the contradicting situation arises. No, situation is not yes also, not no also. It may be between hanging. Then the program, your work should not suspend or stop there. Your work should move on with the alternative which is provided in the algorithm. Okay. So add further details and description required for process. If any further description is required, for your algorithm, it must be added. Consider the capabilities of computer language. So when you are writing algorithms, since we are writing for further ahead moving for programming, so it must have the option and clarity so that these steps can be used in computer programming using any of the computer languages, It should be such that anyone could use it for computer programming. And number 5, we are moving on to number 5, review entire algorithm. Now, once the algorithm is written, you check it. Check the entire algorithm once again. Your logic is correct, your formula is correct, your whatever things you have written is absolutely correct. Now, you have to become like a machine when you are reviewing your algorithm. Don't think that I have written so everything is correct. Now you have to turn yourself mentally into a machine and then read it as a third person, not you, but as a third person. You have to change yourself into third person mentally, and then you review your algorithm. You have to mechanically check whether your logics are correct, your steps are correct, your formula is correct, you're going in the right direction, and if any problem is there, any complications are there, you have to immediately correct it. Okay. Review entire algorithm. Check the algorithm logically and mechanically to decide accuracy and success of the algorithm. So you have to decide whether your algorithm is going to produce accurate answer, it is going to be successful or not. Try simplifying it if necessary. Try simplifying if necessary. Avoid complications and contradictions. So any kind of complications are there, try to keep your algorithm simple. Okay. And don't have any kind of contradiction situation. If it is there, then it must be clearly mention the alternative for handling that contradiction. Now we go on to, we'll see how algorithm is written. We saw one example up there to prepare a cup of tea. Now this is the formal way of writing algorithm. First one is right here. You can see here in the caption, start. The work is start. Now without starting, how algorithm begins. So to indicate the algorithm has started, we first start with start. Step 2, let the first number be 12. So you're taking two numbers and producing the product. So right here, so let first number be 12. Step 2, sorry, step 3, let the second number be 7. So you're asking user to give two numbers or considering the two numbers. The first number is 12 and second number is 7. Then step 4, multiply both the numbers. So whatever numbers are taken into or accepted, they are multiplied, and then display or print the result. So whatever is multiplied, the result is displayed. So here the word print is there. Now like, and then once the answer is obtained, now it is the end of the algorithm. Step 6 is stop. So once you start the work, you do the work, you end, display the answer, and then you have to indicate the work has finished. So write the word stop. Now examples of algorithms that we get in our daily life. So you might have gone through, you might have seen some places, food recipes. The people follow food recipe book and they prepare food at home, no, for special food sometimes on the holidays time. or likewise also if somebody will try out. Now those food recipes are in the form of algorithm. They write ingredients, they write the steps. No? So all the steps that we consider from first to last, these all steps are a kind of algorithm. They are also algorithm. They are telling you how to complete a job of making a particular food, a particular recipe. Okay, for all different food, there will be all different recipes. So for different jobs, different algorithms are there. The same manner. So this food recipe is one example of algorithm. Number two, installation guide of any item you buy. You're buying anything that you buy online that comes in a packet, that comes in a box, and it is not assembled. You have to open it up and then you have to assemble it. In the box, you find a leaflet showing that this is how you are going to install it. Step 1, step 2, step 3, step 4, step 5. No? Now, that booklet installation guide is also an algorithm. Number 3, tour route guiding. Okay, suppose you are going to a new place on a holiday trip. No? Now, how to reach out to that place? The tour operator, if you are booking a ticket or if you are getting help from tour operator, they will send you a tour guide route how to reach up to that place, and they'll also show you what are the places you are going to visit. No? So in day one, this, day two, this, day three, this route will go, and this much time will spend here. This time is lunch. So this is also the whole program is also an algorithm. Okay. Now, this number 3, one more is there that is very simple. Suppose your friend is coming from a faraway place and he doesn't know your home. You're inviting him for your any kind of function, no? And you want your friend to be there at home on time. So what you'll do when you are writing email to him, you describe all the steps right from his place up to your home doorstep, how he can reach all the descriptions of the taxi stand, the taxis, the route, the directions, the landmarks, everything that you describe step by step to make him reach up to your home is also an algorithm. Simple as that. Okay? And this must be clearly mentioned in simple English. No, if you put any steps in a wrong order, then you know that disaster will be there. Your friend might not reach your home. You may reach your relative's home some other place, or you may reach to an unknown person's home somewhere else. So the steps must be accurately mentioned in a proper systematic way. Number 4, instructions of do-it-yourself experiments. There are a number of experiments given in the book, or you come across these experiments. You can do it by yourself. No? Some experiments, some of the toys, some of the things you can develop by yourself, and there also do-it-yourself experiment also comes with a guide, instruction how you can do that work, how you can carry out that experiment safely, in a proper way, in safely. Okay. The same manner we go to step number the fifth algorithm, fifth example algorithm, guidance step for lab practical and experiment. When you're going to lab for doing any practical, uh, making any gas or a combination of any mixtures or acid testing or whatever, the instructions are given by the teacher, by the technician, by the instructor, by the senior, that how you should proceed this experiment. What are the steps you need to follow? What are the apparatus you need to require? When and how these things must be used? And what kind of answer you get? No. So all these steps, what is given, instructions, guidance in a proper sequence, these all are examples of algorithm. Even over the phone, suppose you are at home alone, your mommy has gone somewhere else. At home, suppose you feel hungry and you don't know how to make noodle, you'll call your mommy. Okay, now how to? I am at home feeling hungry. Now how to make noodle? When she will instruct you over the phone, you do this first, you do this second, you do this third, you do this fourth. Now you mix up like this, you cook like this, you stir it like this, then you serve it. Now all these steps from beginning till the end till you serve in a plate, serve in a bowl, it is algorithm. Okay. So, but these all algorithms are nothing to do with the program. So algorithms are expressed and written in very simple English. Simple English. Okay. Okay. Now see this. These algorithms are given here and descriptions are there. Now these two are another two algorithms given. Start the work, accept the first number A, accept the second number B, then sum up. Sum is equal to A plus B, and step 5 display the sum. So once the sum is calculated, we are going to show the sum and then stop the work. Okay, so it is explained other side. Now same manner you go to next one. Same manner it is start accept time in minutes m. No second, how to get the seconds? Minute into 60 and display s is what? Seconds, and then stop the work. Okay, so this is how the algorithms are written. Now we go to the next one. Advantages of algorithm. Easy to write in simple English. The first and foremost, very easy. The best example, sorry, best advantage. Easy to write in simple English. You can write. Anybody can write in simple English. Easy to understand step and logic. Whatever step you are writing, whatever logic you are putting across to solve that work, it is clear. Number 3, easy error detection even by a common person. So if somebody will go through your steps, whatever you have written, can easily detect if there is any kind of mistake because it is going to be in very simple English. Okay. Now disadvantages of algorithm is, first one, it is time consuming. Actually, it is not necessary for those who are already in programming, those who already know how to write a computer program, those who have already started, those who have already stepped in some 1 or 2 levels of programming. For them, it is not required. It is only for absolute beginners. It is only for absolute beginners. It is time consuming and not necessary for intermediate programmers. Number 2 disadvantage, difficult to show decision making and looping constructors. So it is the algorithm cannot show you decision making if then else, and the repeating of jobs cannot be indicated in an easy way in algorithm. It will be indicated, but for that you may have to take the help of a line, arrow, or any marking, any indication to repeat that work. So which makes it little confusing and complicated. Number 3, complex tasks like switch based works etc. are difficult to express in algorithm. Multi-way branching, using switch case, using iterations are difficult because they are little complicated tasks. No, they are little complicated tasks which cannot be described in algorithm. So up to here we stop. We end up to here. We are ending all about algorithm. So diagrammatic representation of a problem solving is called flowchart. So this is a definition. So what exactly is flowchart? Is the diagrammatic form of algorithm is called flowchart. So when you express the algorithm into a picture form in a diagrams with different shapes for different types of work, different nature of jobs, that is called flowchart. It describes a step with different shaped boxes according to the nature of job processing. Flow of steps are indicated with flow lines. Now from where to where steps are followed, direction is indicated by flow lines. And these flow lines will have arrowheads in the direction of flow, which side in which step the next step will be carried out. The steps are indicated by flow lines with proper arrow indication. It is second step towards programming. So flowcharting is the second step towards programming. Effectiveness and accuracy of a program depends on the flowchart you refer to. So when you are writing a program, if your flowchart is correct, or if you are writing program based on a flowchart which is correct, then you can expect correct program. The program will be correct and it will show you accurate answer. The flowchart in a way depicts correct communication to computer through programming steps. So flowchart is a way to depict or show the correct way of communication with the computer. Now, the correct way that you are describing the work, asking the work step by step to perform in the computer program. It is explained, it is described by the pictures, different diagrammatic symbols, and in the symbols the steps and indications, small informations will be mentioned, and these are all very important tool for making your flowchart in a very effective way. So in a way flowchart in a way depicts correct communication to computer through programming steps. So if you are relying on a flowchart for writing program, then you must draw a correct and accurate flowchart. Then only you can convert it into a program. You can use the steps in a program. So you remember flowchart. Once a flowchart is drawn, the users, different programmers can use different programming languages to follow the same flowchart to get the work done. So using different programming languages, the idea of the same flowchart can be expressed through different programs and the work can be done. So now let's see the shapes. The flowchart symbols which I use in flowchart drawing. So the first one is start and stop. So this is to be given in the beginning and at the end. Okay, start and stop. Look here, it is not exactly a rectangular box, it is rounded corner rectangular box, but you are encouraged to use oval shape. You are encouraged to use oval shape. If you are using geometrical instrument for drawing, you can do this, but if you are using a stencil, flowchart stencil, you will get this particular oval shape for start and stop. Next one is flow lines. You can connect this uh, boxes or terminals with flow lines in different direction, up, down, left or right, it depends. Processing, the next box is called processing box. This indicates the processing of work or writing of a formula. No, it is not for displaying output, it is meant only for processing or expressing any formula, calculating any numbers, or any processing work is done, that is expressed inside processing box. Now next one is input output box. Now this symbolic box or input output box indicates accepting of data, reading of data and input of data from the user from different sources, and also the output of information after calculation, how or what answer is to be displayed, from which variable answer is displayed, that is to be expressed or indicated by this input box. Now the next one is conditional or decision making box. So out here you can see decision making box. It is used for decision making work in a program. Now if then else is a decision making for writing, for expressing the work of if then else which is to be implemented, you can use decision making symbol. So look at the symbol, it is not some other shape, it is exactly. Now in this decision making, one input is coming from the previous processing block or box, and then a decision is taken. Is always is there on top, is followed by condition question mark. Is the condition is true, the flow can go to right hand side or it can go down. If it is flow is going yes true to right hand side, the false should go down. If true is going down, then false should go on the right hand side. So one hand is output is for yes, other hand output is for no. If condition is true, it will go to one side. If condition is false, it will go to the other direction. So it is for decision making. Now next one is connectors. Sometimes the flowchart does not fit in one page, in one part, in one place, or sometimes the flowchart becomes complicated to draw flow lines. No, it may intersect the lines. So the by rule the lines should not intersect each other. So to avoid that, we can use connectors. We can use connectors. So these are connectors. Arrow sign with a circle, and then in that circle a code name matching to the place where you have stopped, where you have broken, and where you are joining. It should be indicated. Suppose if I write A here, then A should have one more place from where I am carrying out. I am continuing. No, so from which place it is continued, both the places it must have A symbol or B symbol or C symbol according to the requirement. All the connectors must have different symbols, not same symbol. You cannot give same symbol. Okay, or it comes in the pairs. The connectors comes in the pair. That means 2A, 2B, and 2C and 2D, like that. You can put numbers also depending on your requirement. You can put symbols also. There is no problem. Then there is another connector which is called off-page connector. So if you are continuing your flowchart on the next page, then you can use off-page connector. So this off-page connector indicates the flow of flowchart onto the next page. Okay, so this is very important. And here you can write page number. In the next page block, you can write page number, continues, and page number this. So you can understand the flowchart is continuing on the next page. Okay. Now let's see the advantage of flowchart. What is the advantage of flowchart? Advantage number one, visually communicating the logic. So the flowchart will visually communicate the logic. What logic you are applying for carrying out the work? It is visually communicated because all the shapes, all different job shapes will be used. You will be using different shapes for different types of work. Now with the description, small description, not big description, very short descriptions, and that will make your logic clear into the flowchart. It acts as a blueprint for writing a program. So as I said, it acts as a blueprint. The basic structure is given by a flowchart, described by a flowchart, which can be directly implemented into a program. Number three, the bugs can be easily located and debugging is easier. So looking at the flowchart, if there is any kind of mistake or problem, it can be located easily and debugging is easier. The correction of the steps, the formulas, or things which are required are visually seen and it can be corrected easily in the flowchart itself. Number four, it is a documented form of program with all necessary logic and steps. So it is a documented form because the flowchart is not made, not written or drawn in the computer. It is to be done on the paper. So it is a way it is documented. If you are doing it in computer, it has to be done in the Word file. It has nothing to do with any of the programming language for input processing and output. It has got only the documented form which you can draw and keep it. It is for a visual reference of your program or a task or a job that you are trying to solve by writing your logics and writing your steps. Okay. Now disadvantages of flowchart. Well, disadvantage. If there is advantage, there must be disadvantage also. Okay. It cannot depict and show the complex logic required for complicated program. So programs are not always simple and easy. Sometimes the program turns to become very complicated. Now simply complicated to most complicated. See, the program is turning into complicated job. The complicated logics are there with multiple conditions inside decision making, with different ways of handling the loop, no, different ways of controlling the loop, no, all three different types of loops. Then in that case, the flowchart cannot handle that complexity of looping and other constructs. So therefore, it is not foolproof that we can use all kinds of logics in a flowchart. It has also limitations. So number two, it is time consuming. Yes, drawing flowchart also is a time consuming work, same as algorithm. Okay. If you already know programming, there is no need to do flowcharting. You can go directly to program. You can directly start writing program. But in the programming also there are rules that you need to follow, how to start, and things should be discussed in the later videos. Okay, so later classes will discuss, and you need to follow certain rules, certain methods are there to start programming. Number three, alteration of flowchart is difficult for designers. So if you draw a flowchart, it is difficult to alter. By chance, some new idea comes up and you want to add in between, you cannot do that. If you want to really add some new ideas, new steps, new modifications, then whole flowchart you have to draw again. The entire flowchart you have to draw again. So it will take another the same amount of time plus the new addition of steps. So it is going to take the same amount of time that is spent for drawing flowchart in the beginning. So it is time consuming, and the correction and modifications in the flowchart is not easy. It takes really long time. Step 4, especially stencil is required for drawing accurate and exact flowchart in large scale. If you are going on drawing a large, a complicated flowchart, then you need a stencil. We get a stencil in the market in stationery shop, and then you need to get that stencil for drawing flowchart. So flowchart stencils are available. You have to get this flowchart stencil if you want to go for drawing a large number of flowcharts, a huge and a very complicated and detailed flowchart for really making a professional software or any kind of program. So you need to have a stencil. Otherwise, generally people what they do is that when they start drawing the flowchart symbols, some people forget the symbol shape. So they start drawing flipped or opposite kind of shapes. I've seen the parallelogram input output box. Number of students they start drawing another shape, flipped format of the input output box as they go on drawing. So they forget the shape. So you need to remember the shape should not change. The shape must remain same to depict that kind of work that you are doing in the program. Sorry, in a flowchart that you're indicating in the flowchart. So number 5, it is just a sketch plan of a program on paper. So flowchart is just a sketch plan. It is not real program, but it is just a plan for a program. It cannot work in computer. This flowchart cannot work. So you need to convert it into programming language. So programming is required to execute the idea of the flowchart. So you need to write a program in order to execute the idea of the flowchart, and flowchart itself cannot work for any processing work, any kind of work that you want to do in the computer. Now next one, the rules of flowchart. Now how you should write and what should be there. The flowchart must have start and end and start and stop. So you must start the work in the beginning, indicate that work has started, then you go on, take the value, use the formula and the decisions and this and that, and then when the output is produced, last step must be stop. Indicate the work has over. Work is over. Now flowchart has stopped. Okay. Now number 2 is correct symbols. As I have already reminded, you must use correct symbols for different types of jobs and works in the flowchart. What kind of work you are doing, processing you are doing, you have to use processing box. If you are doing input output, then you have to use input output box. The symbols must be accurately drawn on the flowchart to indicate the work that you are doing. Number 3, correct direction of flow lines. Now, correct direction of flow lines. The direction of flow lines arrow must be in the correct place, in the correct direction. If the arrowheads are showing indicating in 2 directions and 3 directions and complications, so then your flowchart is going to be wrong. So in flowchart, one arrow, one line comes out from one box and then goes to the next terminal box, and this must be indicated by the arrowhead from where it is coming and to where it is going. So only one arrow must be there in one flow line. Then next one, step number 4, remember only decision symbol has 2 outputs. So decision symbol, like here you can see in the example, is a is more than 0. Question, is a more than 0? If the value of a is more than 0, yes, then print positive. If no, then go to next. No. So here input, the decision box has got one input and two outputs. One is for yes and other one is for no. If condition is given here is true, it is yes. If condition given here is false, it is no. So two jobs are carried out, either this or this, either yes or no. Either if condition is true, either print positive or go to the next and check for being the number as neutral number or negative number. Depends on what work we are doing. Okay. Take care of flow lines from decision box. Now, flow lines when they are coming out from decision box, always there are two flow lines coming out. One in the direction of on the right hand side and one in the downward. No flow line comes out from the left hand side decision box. That is a wrong rule. By rule, it must come out from right hand side only. Okay, and one flow line should go downward. Then number 6, avoid complexity of flow lines using connectors. Now do not use too many connectors. Do not use too many lines to intersect each other. If you are drawing lines in simple flow charts and by chance the lines are intersecting each other, use a jumper sign. Jump sign looks like they're like a speed breaker sign you have seen, no? A speed breaker on the road. They are like just small inverted U, no? Inverted U looks like, okay. So small bridging sign must be given on the lines wherever it is intersecting. So that is indicated that line is not crossing, but it is jumping over that and going in its own direction. Okay. So avoid complexity of flow lines. Use connectors, in-phase connectors and use off-phase connectors. So avoid intersection of flow lines using and use jump symbol. Now next one is with this I think these are the rules that we need to follow for drawing flowchart. Now examples of flowchart, you can see there are three examples I will show you, and then the first example is see here start. The flowchart starts with the start box. Then you can see the parallelogram here. It is not rectangle. Parallelogram input when it is asking something and displaying something, then input parallelogram is required. Input and print. The input is asking and print is displaying. It is input is taking and print is giving out. So here input A comma B. That means asking the input the value of A and B. Give me the value of A and B. I am going to input or take the value of A and B. No, the A and B value will be given by user. No, whatever be the value of A and B separately. Then C is a formula. Look here, C is equal to A plus B. It is a formula. It is a processing. It is inside the processing box. And then C is output. So print C. The next step is print C. So C is calculated, sum is calculated into C, and then print C. That is displaying the sum, and work is over. Stop. The second one is here start the work input A. So take the value of A. Input A means taking the value of A. No, input take a value into A and then go for condition checking. Is A more than 0? Is A value more than 0? Question mark. If yes, that means number is positive. Print positive. Now display indication on the screen that the number is positive. If after printing that it has to continue going down to stop. See the line. It is flowing downward and going to join after it is going to directly to stop. Joining to the line of stop. Now if no, if the number is not more than 0, then no is less than 0. Again checking is done. Is A less than 0? If yes, then you can say it is negative. If A value is less than 0, it is obviously negative. And after showing negative, it is going to end the work. And by chance, if it is not more than 0, not less than 0, then it is understood no, it is neutral number. So here it is automatically understood A is 0. If it is not more than, if it is not less than, then it is equal to 0. So therefore given here, if yes, negative, if no, neutral, because positive is already checked here and work is stopped. Okay. Now let's go to the next flowchart. Very simple. Start the work, take the value of A and B, input A and B, asking user to give value of A and B. Now formula to calculate what? Average. Average is calculated. Average is equal to A plus B divided by 2 because there are two numbers. So this is a formula. And out here the taking value of A and B is taken here, and the value of A and B is utilized for adding, divided by 2, and the average is calculated in ABG. Now is ABG, it is checked here, is ABG average is more than 50? If yes, then pass and stop. If no, then fail and stop. If somebody's marks is getting average more than 50 is coming by adding A and B, then that it is fast, yes, stop. Coming down here, stop. If no, is average is not more than 50, then it is failed. Now this flowchart has got a small problem. By chance you have considered someone to see that if somebody is getting 50% also pass, then here it must be average equals to more than, equal to more than 50. Equal to sign should be added here with more than sign. So it should be more than equal to 50, then pass, else fail. Didn't fail and stop. Okay. So these are the three examples of flowcharts, and you may see more flowcharts are there in your textbooks. Now you have to try learning. You have to try learning flowcharts. You have to try learning writing algorithm. So first you try learning algorithm. Assignments will be sent to you, and the flowchart questions also will be sent to you. You can try out, and all the best.